looks at the graphing calculator. So as a requirement of the course, all of you were asked to purchase a graphing calculator that you will be able to use for the next 3 years in Dash 1 and in Dash 2. The nice thing with the workbook is the workbook goes through how to use the graphing calculator. If you decide to not keep the workbook after this course, keep this section from the workbook because it is very useful. Tag it, mark it, do something so that you can easily find it. So the first thing that we need to do is we need to prepare the calculator in order to graph. So what you want to do is you want to make sure that the calculator is in function mode, which unless if you've been playing around with your calculator, it would be in function mode. So if I press the mode button, I can be in function mode. There's parametric, polarimetric, and sequential. In 13 years of teaching, I've never used those three. I stay on function mode. That's really all I need to worry about. The connected, the sequential, the real, the full, all of those things, I've never played around with them on the calculator. I don't split things all that often. I just go back and forth between two full windows. Normal, scientific, and engineering. We did look a little bit at the scientific form earlier when we were looking at scientific notation, but again, I usually leave it on normal. This float has to do with decimal places. If I put it on 0, it will not have a decimal place. It'll round everything to the nearest whole number. If I have 3, it'll round everything to 3 decimals. So even if I put in 2 plus 6, it will give me an answer of 8.000 because it expresses every answer to 3 decimal places. Again, I leave that on float. The only time I've ever changed it is when I'm doing the finance unit and I change it to 2 decimal places because we're talking about money and it just makes it easier. But again, I just leave this screen alone. Then we look at our window. So if you press the window button, which is the second gray key along the top, what you get is a window. Now your window, let me just do something here. First of all, clear that. Is that what your window looks like? 10, negative 10, 1, negative 10, 10, 1?
That's a 0.
Okay, so you might have actually used yours to do some graphing at this point. But if you wanted to change it to a negative 10, you just type in negative 10. If I want to change this to negative 30, I just type in negative 30. And I can go up and down. So what this means is the X-min means that when I put a grid, so if I press the graph button and I have my grid, this is negative 10. That's my minimum X value. Positive 10 is my highest X value. And then that X, SCLE, stands for X scale. What are my little tick marks? What am I going up by? So if I change this to be 2, notice my tick marks get further apart. If I put an X scale of 0, I actually have no tick marks. So I can change what my scale is if I want to, if I need to. Everything below Y scale, don't change. Leave it exactly as it is. Don't play around with those. So really all we ever concern ourselves with is from the X-min to the Y scale. When it comes to graphing, your window settings are probably the thing that takes the most practice in trying to figure out, because you want to be able to see parts of the graph that is going to tell you information. So if it's a straight line graph, most of the time I want to see where does it cross the X and the Y axis. If it's those quadratics, that parabola shape that goes, that U shape, I want to see where did it change direction, where is the U? Does it cross the X axis? If it does, I want to see where. So most of the time, those are what we're looking for when we are graphing. Then we have our format of the calculator. So if I press second and the zoom button, so in blue above it says format, everything on the left-hand side should be highlighted. Again, in 13 years, I don't ever play with this screen. I leave it exactly as it is. When your calculators are reset when it comes time for final exams, it stays like this. This is the default settings. And then we have the y equals button. This is called the y equals editor. And it is where we put in our equations. It is where we would put in the equation that we want to graph. So the equation, or sorry, the other thing is we want to make sure that these plots up here, that none of them are highlighted. We will get into those later, but for now, with what we're graphing, we want these to be off. Okay? So what we're going to do is we're going to graph the same equation, and we're going to look at that equation, and we're going to work with that equation on some of the features of the calculator. So the equation that we're looking at is y equals negative 1.25x plus 15. So if I go to type this in, negative 1.25, and then for the x button, there's a button right beside the alpha. It says x, t, theta, and n. Basically, it's my variable button. When I press it, I get x. It will never put in t, it'll never put in n or theta, it will always be x. Okay? So the question that we were doing the other day with the toothpicks, the p and the t, it doesn't matter. On the y equals editor, the p would be y and the t would be x. And then I have plus 15. So if I press the graph button, how many of you got that for your graph? Elena? Okay. Okay, what's the problem with this graph? With this picture?
You can't see the intercepts.
I can't see where it crosses my axis, and I have basically 3/4 of the screen that has nothing. So I want to alter my window settings. So I know that I need to extend my X's. So I can press my window, and I know I don't really actually need to go into the negatives too much, so maybe I back it up and I go to -5. And then instead of going to 10, maybe I try to go to 20 and see what that does. Now, maybe at this point I want to change my scale, or maybe I want to leave my scale as is. I'm going to go 5, just so I don't have as many tick marks distracting me. If I press graph after this point, now I get to see where it crossed the x-axis. And now I can do the same thing for the y's. I need to extend my y's to go up a lot higher. So I can go through, again, maybe I don't need my y's as much. I don't need that negative part. I want the positive part. So I bring it up to 20 and make this go up to 5 again. And then I press graph. And now I can see more of the graph. I can see where it crosses the x and the y axis. So that's one way that I can adjust the window settings, kind of by a guess and check method. There are other ways that I can do that. So if I start off this zoom menu. So this zoom menu, Z standard, which you've seen me do a couple of times, that's my standard 10 by 10 grid. So if I go zoom standard, it will take the X and the Y window and make them go from -10 to +10 with a scale of 1. That's what zoom standard will do. Zoom decimal is for kind of using the place where we use zoom decimal the most is when we're dealing with rational equations. Most of the time, I don't use zoom decimal. Zoom trig, we use in grade 12 when we're graphing trigonometric functions. Zoom in and zoom out, I don't like using them either. And the reason why I don't like using zoom in or zoom out is because if I use zoom out, first of all, I have to move my cursor to where I want the zooming to be done. comes out from that location. But my numbers start to become really off. There's a lot of decimals that I have to worry about, and it's not a great use of the shape of the graph. So what I prefer is when I get to this zoom standard, and if I have to extend things, if I want to see things, the way that I can do that, I can try to do the guess and check, which is what we did from the -5 to 20, or I can look at what is the table of values doing, because your calculator can do a table of values for you. So if you press the second button and the graph button where it says table, now I can see the table of values. So the other day when we were doing the input and the output for the car, I could actually put the equation into my y equals, and then I could go to my table and I could look at the table for my inputs and my outputs. So from here, what I can start to look at is I can start to look at, well, when x equals 0, y equals 15. There's my y-intercept. My numbers are going down, so I'm going to see how long it takes until I get a 0. When x is equal to 12, y is equal to 15. So I can use the patterns within the table of values to help me identify a suitable window setting. So the last thing when we're talking about window settings, and we're already on the second page, is when we are talking about window settings is the way that we write them in. So when we are expressing our window settings, the way that we write it in is we have x with a colon and then square brackets. And we list it as x min, x max, and x scale. So for what we were doing when we went from -5 to 20 with a scale of 5. They did their y axis a bit different, -10 to 25 going up by 5s. But it is in the exact same order as the window setting itself. So I just have to write it down in the order that I see it for the x and for the y. With the zooms, so it's zoom standard, we talked a little bit about zoom trig. Zoom fit, which is actually choice 0 later on right here. If I press zoom fit, so I press 0, what it does is it fits the information. So it looks for the y-axis, it looks for changes in shape, changes in direction. And then what I can do when I have this is if I press my window button, notice it changes some of my settings. So it was going from 2.5 to 27.5. So maybe I want to change that to back it off to be -5. And then maybe I bring this up to 30. Take a look at what it looks like. I now see where it crosses the y-axis, and then I can make the adjustment for the x-axis. So zoom fit just kind of helps focus your attention on a certain area of the graph, but I would always go back in and adjust the window settings to get rid of that decimal type system. So the table of values. I've already shown you how to access it. We go second, graph, and there's my table. But what I can do before I access my table is I could set up my table. So in the question that we did with the banquet the other day, we were going up by 100 people, 200 people, 300 people, or we were going up by 50s. Well, it'd be really nice if we could get the calculator to do that with our x's. So where we get that menu is if you look above window, it says table set. So we go second, window, and then I can fill it. Where do I want to start my table? So with that banquet question, if I wanted to, I want to start my table at 100. Oops. 100. Science class, what is this symbol? The little triangle.
Delta.
Delta, what does delta mean? Pardon? So if I was doing
change.
a change in something, so what do I want to go up by? So again, if this was my banquet question, go up by 50s. And then the independent and the dependent with auto means it'll automatically calculate it. So if I did that and I went to my table now, my table's going up by 50s starting at 100. So that's one feature that the table can do. The other feature that the table can do centers around this independent, this auto and ask. And more so the independent. Don't worry about the dependent, it's the independent. If I go down and I go to ask, and I leave the dependent on auto, and then go back to my table, notice my table is blank. It's because it's waiting for me to ask for the independent variable. So if I say, what is the value of the graph when x equals 3? So I press 3 and enter, and it gives me the answer, 11.25. If I wanted to know what's the value of the graph when x equals negative 2.5, and I press enter, it gives me the answer, 18.125. So that's what the table feature can do for you. Any questions on that? The only thing to remember is, let's go back now to the table set, and let's start our table at 0 and go up by 1s, so that when we're doing our questions later on, it's not going to mess us up. And we're going to put this back on auto. So now again, if I go back to my table, starting at 0, and it's giving me those numbers going up by 1s. Okay? The last thing that I will show you before I get you to work on some questions is I can split the screen. I don't like doing this because really it squishes everything. My screen's not very big to begin with. But if I press the mode button, and I go down at the bottom here where it says full, horizontal, and GT, GT stands for graph table. So if I go down and I highlight it and press enter, and then press my graph button, I now see the graph and the table at the same time. But then I need to remember to go back to my mode and fix it if I want to see the full graphing screen. Okay? So what I would like you guys to do is question number 1. And what I'll do is I'll give you about 15 minutes. I'm trying to remember how many parts question number 1 had to it. We'll look at 15, 20 minutes, and then we will actually review what the graphs look like. So for question number 1, what you have to do is you have to graph each of the following equations. So I put this into my y equals editor, 0.5x minus 8. And then I adjust the window settings so that I could see the x and y intercepts if they're applicable. Meaning in some of these graphs, you can't actually see an x or a y intercept because it doesn't actually cross the x-axis or it doesn't cross the y-axis. But you'll be able to tell that through the general shape. And then you're going to sketch the graph and then write an appropriate window setting. The note, reset your graph. Go to Zoom Standard after each time after you've played around with your window settings and start again. Okay? When you're putting your questions into the calculator, there are two different minus buttons on your calculator. There's a negative button and there's a minus button. So if I go to put in 0.5x, let me put it off, 0.5x, and if I go minus 8, I get this for a graph. Oh, I forgot to zoom standard it. Let's start over. So there's my zoom standard. If I instead had written 0.5x and I used the negative button instead, notice the negative button is shorter and it's actually a little bit higher. What this actually says to the calculator is 0.5x times negative 8. And so when I put it that way, I get this for a graph. So make sure that you're using the right button. This is a minus, so it's 0.5 minus 8. So you see that it's a little bit lower and it's longer when we're talking about a subtraction sign. Okay, so how did these questions go to graph them and to determine the window settings? What advice would you give to those students that aren't here today?
Have fun.
Have fun.
Make sure you change like how you're zooming in and stuff so that you can find the graph, because sometimes it doesn't pop up right away.
Okay. Yeah, so if you go to graph it and the screen is blank, because I think that happens on the 2x minus 15, if you do a standard window setting, there's nothing there. And so if I show you that on the calculator, or not, opening it up again. So if I type in 2x minus 15, and I put it on a standard window setting, I do get part of the graph. But I think there was one further down. The negative 2x plus 128.
Yeah, and D only
Okay.
had like a square, like a dot.
So let's try that one. Negative 2x minus 128.
Plus 28.
Now, something you'll notice when you press the graph button up in this top corner, there's a series of dots that scroll. That tells you the calculator's working on trying to graph it. So as long as it's like the spinning circle, and you better hope that you never get the spinning circle of the scrolling dots of foreverness. So it just tells you that the graph or the calculator's trying to graph this. So if I press the graph button, there's my scroll.
Plus 128.
Oh, plus 128?
Yeah.
I don't think that makes a big difference. But again, plus 128. I look, it's scrolling, and then it stops. So when it stops, it actually means it's graphed it. It's just graphed it where you can't see it. So then you have to adjust your window settings. So that's where you use your table of values. At 0, the graph is starting off at 128. And at 1, it's coming down. So at negative 1, it's still going up. Which means my window settings in my standard, at 0, I was 128 in the air. So I need to adjust my y's. My y's need to go up to, maybe they need to go up to 150. And then my scale could be tens. If I try that, now I start to see it crossing the y-axis. So I actually have a point to start from. Then I can look and I can figure out, well, where's it going to cross the x-axis? So I start to, in a sense, almost extrapolate. So if it's at 10 here, if I keep bringing it out, well, gee, I'm going to need some pretty high x numbers. So maybe in my window settings, maybe I bring my x's to 100 as well. Not 111. And then see what that does. And now I can see both intercepts of my graph. So then when I go to register that as a window setting, I would have my x from negative 10 to 100 going up by 10s, and I had my y's at negative 10 to 150 going up by 10s. And then I can see my graph went through. And that's all I need, is just to sketch the general shape of this graph. So our table, I find the table of values to be the best tool to help me narrow down how to adjust my window settings. I find I'm less patient with the zoom fit and the zoom decimal and all of those other things. The next thing that I'm going to show you is how you can find x and y coordinates on the graph. So we go back to our grid that we had. We are going to go back to our original equation, which was negative 1.25x plus 15. And if you look at the graph, it's actually on this page, 436. It is giving you what they want you to have for the window setting. So it gives me the window setting. That's what I'm going to put in. Negative 5 to 20, going up by 5s, and negative 10 to 25, going up by 5s. And then we're going to graph this.
Well, I think that's it.
So in order to see, or in order to move along this line, if I press the trace button, all of a sudden a whole bunch of stuff appears on the grid. In the top left-hand corner is the equation. y1 equals negative 1.25x plus 15. And then along the bottom I have x and y's, and then I have this cursor that's flashing. If I move left or right, the cursor moves along the line and the numbers change. Now, realistically, if I'm trying to find a value, I'm not looking for when x equals 9.6276596. I'm looking for things like when x equals 6, when x equals 5. So what I can do to determine those y values when I'm given an x value is, once I've got this cursor on the line and I've pressed the trace button, I can just press 9 and then press enter. And what happens at the bottom of my screen, I have x equals 9, and then I have the y value. And the cursor is actually flashing on the line. So the cursors jump to that point when x equals 9.
I was thinking the same thing.
And then again, if I wanted instead x being negative 1, it now jumps to where negative 1 is. So I can jump back and forth on my line. The other way that I can do this is I can press the trace, or sorry, not the trace key. I can press the second button, and whenever you press the second button, I get an arrow that shows a shift, and then the trace. And I get this calculate menu. So then I can pick number 1, which is value. And when I pick value, then what I get on the screen is x equals. And again, I can type in 5, enter. So I can either press the trace button or I can go into the calculate menu to find those values of x. To find the value of x when I'm given a y value, I don't have a y equals calculating tool in here. However, I do have a y equals editor menu. So if I wanted to know what's the value of x when y equals 4, what I do is I let y2 equal 4. And then I press the graph button and something's going to happen. What happened? I get this horizontal line. This horizontal line. So this horizontal line represents y equals 4, because no matter what the x value is, y is always equal to 4. In fact, if I went to the table of values, it now gives me the values for y1 and for y2. And if you notice, all the values for y2 are equal to 4. So now if I go back to my graph, what I'm looking for is I'm looking for this right here. Because this is the point where both this graph, which is y equals 4, and this graph match up. So this would give me the x value that they had the same y value for. It's the intersection between the two graphs, which I can find by going second calc. It's choice number 5. It says intersect. So now when I press 5, I get a whole bunch more information on the screen. First information I get is first curve. First curve means you're on the first graph. So I can scroll up and down that graph, but really I'm trying to get to that point of intersection, as close to it as I need to be. Because what I need to do is I need to tell the calculator, look in this area for the intersection point. Because sometimes we might get a graph that might have more than one intersection point. If this was a graph that was a quadratic, there'd be 2 intersection points, and I need to tell the calculator which one to look at. So once I have it close to there on the first curve, I press enter. And then if you noticed, this up here changed from y1 to y2, and now it says it's on the second curve. So it's actually on this second line. So again, I want to get close to the intersection point on that second line, which it's already there. It will jump to that close point to begin with. So I press enter again, and now it says guess. So this is based on how close you got it to that intersection point. I have a calculator to do this for me. I don't want to simply guess. I want it to actually calculate. So I press enter one more time. And then the calculator writes up intersection. And it tells me when y is equal to 4, x would be equal to 8.8. Okay? So I kind of did it a little bit differently than what the book did. The book goes through the steps, step by step, only they use y equals 8. So it's all right there on that page, exactly how to find that x value when you're given the y value. So we're going to do class example number 1. Consider the equation y equals 2x minus 25. So let's put that into the calculator. So we can clear. If I press the clear button, that gets rid of my equations. So now I can type in 2x minus 25. And I'm going to press zoom standard. So I go back to my regular Windows settings. And I get a partial line right here. So what part of the graph do I need to extend? So my positive x I need higher, and my negative y's I need lower. So I can, instead of starting at negative 10, maybe I start at negative 5. What should I go up to?
40.
40. Okay, I think 40 is a little bit more appropriate than 1,000. What should I be going up by? Short. Okay, and then we said my y min needed to be lower. How low should it be? Negative 30, okay? And then, could I leave it up to 10?
Yeah.
Okay, and what should my scale be? Short. Graph. There we go. Now I can see the x and the y intersects. Okay? If I wanted to use up more of the screen, I could just shorten up my x's. And instead, because I know that each of these is 5. 5, 10, 15. So I don't need to go up to 40, but I can just leave it at 40. It's not going to be the end of the day. So I have to write this in. Negative 5 to 40 going up by 5s. And then we went from negative 30 to 10 going up by 5s. So then we're asked to find the value of y when x equals 4.5. So I press trace, and then just type in 4.5, not 45. And when I type in 4.5, what does y give me?
Negative 16.
-16.
Sorry, I was supposed to come see you. That's all the ticket money for 21 to 30.
Oh, okay.
Who can I get another 10 from?
Connie doesn't have any of the office.
She didn't say anything. I should ask her then maybe.
Yeah, there's a cash box at the office, and then bundles of 10. So that's Connie.
Perfect.
If not, when the bell rings, like.
Okay, thanks.
Okay. I'm going to let you verify this algebraically on your own, because you guys are smart and you know how to do that. Find the value of x when y equals -6.4. So what I have to do is I have to let y equal -6.4. And then I press graph, and now I use that intersection feature. So if I go second trace, intersect, which is number 5, try to get close to that intersection, press enter 3 times until the word intersection comes up. And what is the x value equal to? 9.3. So I have that x equals 9.3 here, and what did y equal in the first one? -16. And my graph kind of looked like this. Okay, so what I want you to practice doing is questions 3 AC and EG and 4 ACEG. So today we're going to continue our exploration on the graphing calculator and how to use the graphing calculator to graph functions and then how to get information from the functions. So on Friday, we had looked at graphing the functions. We looked at changing the window settings of the function. And then we looked at the table of values as well as finding the y-coordinate and the x-coordinate of a point on the graph of the function. So we were starting to use some of the calculator menu items on the graphing calculator menus and seeing what they did to the graph. So what we're going to do today is we're going to continue our exploration. We're going to use the calculator to determine our x and our y intercepts. And then how do I get the calculator to express things for me as a fraction when I'm on the graph? So the first thing that I need you to do is grab your graphing calculators and turn them on. So when we are trying to find the x-intercept is where it crosses the x-axis. So there's two methods that I can use to find this. I can use an intersection feature, in which case, in order to use the intersect, so that's second calc number 5, in order to use the intersect, you need to have 2 equations. So in your y equals editor, you have to have a graph for y1, and you have to have a graph for y2. If you do not have the 2 equations, you're not going to be able to find the intersection between the 2 equations. So if we start off with our general line that we had drawn the other day, which is right here. So you're told what to put into y1. y1 equals negative 1.25x plus 15, and you're given the window settings. So if we were to put that in, we've got y1 equals negative 1.25. The x variable is the one that's right beside the alpha. It says x, t, theta, and n. So that's what we use for our variable, plus 15. Then if I press the window button, Here comes my window setting, so that gives me what my x's will go through from the smallest to the largest and what my scale would be, and then my y's. So I'm told my x's have to go from -5 to 20, and my scale will be going up by 5s, and my y's will be going from -10 to 25, going up by 5s. So if I was to press the graph button now, this is the graph that I should get. If you don't have that graph, please put your hand up. Okay, secondly, in order to use the intersect to find the x-intercept, now I would go through and I would let y2 be equal to 0. And I'd press graph again, and remember I pointed out on Friday you get that little scrolling line in the top corner that tells you the calculator's working. So if I press graph, it tells me it's working, but nothing shows up on the screen. And the reason why nothing shows up on the screen is because the equation y = 0 is the x-axis. So suppose I wanted to see for sure that that was the x-axis. Is there a way I could do so? Yes, there is. Thank you for asking. If you go down to y2 and go over to the left-hand side and put your cursor over top the little diagonal, if you press enter, that line thickens. It's what you can use to draw different types of lines. Primarily, these are the two that we use. The little skinny one and the thick one. Now if I press graph, there's my first line, and now you can actually see it physically draw the second line, which can be useful especially when that line is the x-axis. So now if I wanted to find the intersection between the two, second calc, intersect, and then I can move the cursor close to that intersection point. First curve means it's on the first graph. Press enter, second curve means it jumps to the second line. I press enter again, it says guess. I press enter one more time, and up comes the intersection. So when x is equal to 12, y = 0. That becomes my x-intercept. So that's the intersection feature. The other feature that you can use is called the 0 feature. So what I'm going to do first is get you guys to go through and clear out y2. So highlight y2 and then just press clear. And then you're going to go second calc and 0. The values are those x-intercepts the calculator recognizes as a 0. When you press 0, what happens is you get the equation, your cursor's on the line, and then it says left bound. What you have to tell the calculator is where to look for the x-axis. I want it to look in this area. So I want to be on the left side of the x-axis. So on the left side. And then the right bound means I need to be on the right side of that 0. If I have done this correctly, 2 arrows appear at the top of my screen and they need to be pointing each other. If they're not pointing each other, you're going to get an error. The calculator is going to tell you can't do it. Or if you're not actually on either side of the axis, your calculator will give you an error. It says guess. Again, I'm not wanting it to guess, so I press enter a third time, and then it tells me the 0. So possible mistakes that are made when we're calculating the zeros are not getting that left bound and that right bound established. So we go left bound, but we don't go far enough over for right bound. So even though the 2 arrows are pointed to each other, I'm not actually on the right side of the 0. So then when I press enter again, what comes up here says no sign change. And the no sign change has to do with the y values. So if I quit and I try again, look at your y values. on the left side, my y value is positive. On the y side, on the right side, my y value becomes negative. In order for it to calculate as 0, it has to have a sign change from positive to negative or negative to positive, depending where your 0 is located. So sometimes your 0 might be negative y values on the left side and positive y values on the right side. Or it could be reversed. So it does take some practice, but everything is spelled out in the procedures. So it tells you exactly what to do. Enter the equation key, press second trace, and choose number 2 and press enter. And then it tells you left side and right side, and goes through the steps. So this is how I would calculate the 0, or the x-intercept. And the reason why I have to do it this way is because I can't tell the calculator to let y equal 0 unless I use the y-editor. Finding the y-intercept is easier because the y-intercept happens when x is equal to 0 along this axis. So if I was to use my graph that I have and I wanted to find the y-intercept, if I press the trace button and then press 0, x equals 0 appears on the screen. Press enter, and it jumps to that point on the graph and tells me when x is equal to 0, y is equal to 15. The other way that I could do this, if I go second calc, and I can pick one which is value, and then it prompts me, x equals what value? I want x to equal 0. I still get 15. So if you look on in your workbook, the equation that they have is negative 5x plus 60 over 4. Believe it or not, this is the exact same equation as what we have. Because 60 divided by 4 is 15, and negative 5 divided by 4 is negative 1.25. It was just another way of writing the equation. Any questions so far about the y and the x-intercepts?
How do you get the x equals 0?
The x equals 0? I can either press trace and just hit 0, which is probably the easiest, or I can go to my menu, second calc, and then number 1 for value, and then it prompts me x equals 0. Okay, so let's look at, there's another way that I can find x and the y-intercept. I can go to my table. When I go to my table, what I'd want to do though is I'd want to go to my table set. And I want to change my independent variable to asking because I want to put it into the table. That when x equals 0, what would y equal? So once I've changed that to ask, I can go second graph, which is my table menu because it's in blue. I get this blank table. I can type in x equals 0, and I get y equals 15. Okay? And so let's look at class example number 2. In each case, use the features of a graphing calculator to calculate the x and y graphs, where x and y intercepts of the graph of each relation. So if I we'll stop here for a moment. So class example number 2 looks at using the features of a graphing calculator to find the x and the y intercepts of these relations. So if we start off, we clear the equation that's in y1. And then we're going to put the equation for this equation in here. So this right here is a division bar, which means I want to do the top calculation before the bottom. So to show that on my calculator, I use brackets. Open up your set of brackets, and then it would be 5x plus 15 and then close the, oops. Multiply plus 15 and then, there we go. Then I would close the set of brackets. And then that would be divided by 3. So that's how I use the division bar in my calculator. I use brackets. So the best thing to do is always start off with your standard grid. So that's pressing zoom and 6. And then it graphs it. And what I want to check for is, can I see the x and the y intercepts?
Yeah.
If I can see the x and y intercepts, I don't need to do anything further because all I'm doing is finding x and y intercepts. How do I find the y-intercept? How do I find this one?
X equals 0.
X equals 0. So I can press trace, 0, and enter. And what is y equal to?
5.
So then my y-intercept equals 5. To find my x-intercept, second, calc, and which choice do I use? The 0. So choice number 2. Now left bound means I have to be on the left side of this x-intercept, which means I need to be into the negative y values. That's the left side. I press enter and the arrow appears. Then I need to move to the right side. So I need to watch for when my y values become positive. Once they become positive, I can press enter again. The arrows are pointing each other. I press enter one more time. And then my screen says 0, x equals -3, y equals 0. So my x-intercept then would be -3. Okay, so let's look at B. So clear your equation. -x squared. So the negative button is this button right here. So I talked about it the other day, the difference between the negative button and a subtraction sign. This one, I would have to use the negative button, x, and then I can use my squared. So x squared plus x plus 6. I'm already on my standard window setting, so I don't have to go zoom 6. I can press graph. And then I have this upside down shaped U. Do you guys remember what we called this?
Quadratic.
A quadratic. So the shape is called a parabola. The equation is a quadratic equation. So how do I find the y-intercept of this quadratic equation? Trace 0. And the y-intercept is 6. And the y-intercept is 6 because x is equal to 0. These two terms cancel out. 0 plus 0 plus 6. How many x-intercepts do I have? 2. It crosses the axis in 2 places. So I'm going to give you a couple of minutes. I want you to find both of them using that 0 feature. Okay, so what are my x-intercepts for this graph? -2 and 3. Which in this case I could probably even look and see that it's going through. And I could even probably look at my table. And what I'd be looking for is when are the y values 0. So sometimes it works to look at your table because I can see the x equaling 0, I can see the y equaling 0. But if it's not a whole number, then it doesn't work as well. So x-intercepts were -2 and 3. Oh, I have a quick question. Actually, no, I don't. Never mind. Okay, fractions, decimals. If the x or the y-intercept is not an integer, the calculator displays it in decimal form, always in decimal form. The calculator does not do fractions on the graph. So if I wanted to trick or convince the calculator to put this into a fraction for me, this is the procedure I would go through. So first thing that we need to do is we need to put in a different equation. So our equation that we're going to put in is bracket 2x minus 11 bracket divided by 7. And I think that we're okay with our standard window settings.
Yeah.
Press the graph button. Can I see both the x and the y intercepts? Yes, I can. So let's start with our x value. Let's find the x-intercept. So how do I find the x-intercept again? What do I use to find the x-intercept?
Calc 2.
Second calc and 2, so I find the 0. And what do I get?
5.5.
5.5. So there's two ways that I could do this. Both ways involve going to your main screen, which I get by going second quit. So what was that 0 again? 5.5. So I could type 5.5, then press the math button, and there's an arrow that says frac. I press enter, so it says take 5.5 and make it into a fraction. 11 halves. Now suppose the number wasn't 5.5. Suppose it was 5.1623 repeating. That's a lot to have to remember to try to put in. Press the X button on your screen and then press enter. What happens? It gives me the number that was just in my graph, and then I would repeat the process. Okay? So go back to your graph. How do I find the y-intercept? X equals 0, so I could go trace 0. And now I get something that I don't want to have to put in the calculator. Negative 1.571429, blah, 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 blah. Quit. Now, this one's a little bit trickier because now I need the calculator to pull up y. So if you notice on your calculator, you've got all these green buttons. Where's the letter y?
1.
You go alpha 1.
So alpha 1 and the letter y comes up. Press enter and there's that number. Change it to a frac by going math, enter, enter, and there's my negative 11/7. So it does go through the procedure down below. Enter it in the equation y1, find the y-intercept using the trace, press second quit to exit the graph display, press alpha 1 to access the letter y, press math, enter, enter. And then the decimal value may be verified by dividing the fraction. So if I went negative 11 divided by 7, I would get that negative 1.57 on and on. So I would like you to work on questions 6 and then 7, A, C, and F. Okay, the last part that I want to go through with you looks at determining max and minimum values. So in order to, what you can do is you can use the calculator to determine a maximum point or a minimum point on the graph. In order to have a maximum point or a minimum point on the graph has to change direction at some point in time. So the ones that we're looking at is we're looking at these quadratics, these parabolas. So this right here would be the maximum point. This is as high as the graph is going to go before it turns back and starts going down again. So if we were to enter that into our calculator, this is the equation that we're going to put in. So negative x squared plus 5x plus 14. And then we have window settings that were provided to us. So we press the window button, negative 5 to 10, going up by 5, so that's what the x scale means. Negative 5 to 30, going up by 5s. And then if I press graph, I get this quadratic. And what I want to know about the quadratic is I want to know about its maximum point. I want to know the maximum point right here. So the way that I do that is I go back to that calculate menu. And it's choice number 4. Not number 3. This is the maximum point. When you press that, you get that left bound, right bound. Left bound means be on the left side of the maximum. And then press enter and an arrow appears. Then it says right bound, so it says get to the right side of that maximum point. Press enter and another arrow appears. We want to make sure the 2 arrows are pointing each other. We press enter again, and it gives me the maximum. Now in this case, it gives me 2.50000 and 13. We're going to count this as a 2.5. So the x-coordinate is at 2.5. The y-coordinate is at 20.25. So if I scroll down, we're at this point right here, and I've got 2.5. This one on this screen was giving me 2.4999978, and then 20.25. I can change that into a fraction, and I can get 81 quarters. Now, this number 7 talks about why the 2.499 and the 2.500. Due to the limitations on the calculator, the x value on the display sometimes varies from calculator to calculator. The answer obtained may depend on the window settings used, the boundaries. It could even have to do with the resolution settings. All the answers, however, should be rounded to the exact answer in this case, which would be 2.5. And I could test that. If I took my calculator and I went trace 2.5 and then went enter, notice how my y value stayed what it was. It stayed that maximum point. Okay? So what you can practice with is question 8a and 9a.